What we're looking at in this video is something called flowcharts or flow diagrams, and you've probably seen these things around in general on posters or in books. And we're just going to look at how we can make these run algorithms. And so we'll look at some examples first, and the first one we're going to look at is adding two numbers together. And so every flowchart or flow diagram, we have to start or begin. And the symbol we use for that is kind of like a bit of a sausage. And then we've got to get these two numbers in. So input A and input B. Now inputs and outputs get put into a parallelogram, so slanted edges like this. So input A, input B, and then we join them up and show the flow through the diagram or the chart. So I'm going to start for my program, then I'm going to input A, then I'm going to input B. Then I need to do some processing with them because I'm adding two numbers together. So the result will be A plus B. And because I'm processing, I use squares or rectangles, so vertical edges. And I've added the two numbers. I want to print them on the screen, so I'm going to print the result, and because that's input and output, I have the slanted edges and a parallelogram. Let's just do that again. And then to finish, I can use the word finish or end, and again that goes into a sausage symbol. And so that's the first one, to add two numbers. We're then going to look at a second flowchart. This is to find the bigger of two numbers, so it will take two numbers in and it will print the bigger one on the screen. So again, start or begin. I'm then going to take my input, and this time I'm going to take both inputs at the same time, so rather than drawing two boxes, I'm going to draw one. So that will be input A and input B. Remember parallelogram, because that's an input or an output. Then I've got to make a decision, so I'm going to do it's going to flow differently through the diagram depending on a decision that's been made. So I use a diamond for that, and I'm going to say is A greater than B. And I need a diamond like this, and connect that up. And then I've got one direction which will be for A is greater than B, and one direction which will be no, A is not greater than B. So if A is greater than B, then I want to print A on the screen because that's the bigger number. And that's an input and output. And for the no, that means that B must be bigger or it's going to be the same. And so I'll print B, input, output. And now I connect these back together, so show the flow, and then finally finish my program, or end. And so that there will find the bigger of two numbers and print on the screen. That's the flow diagram to do that. And the final one, which we're going to look at, a tiny bit harder, so finding the average of two numbers. But this time, instead of having it all in one flow chart, I'm going to use a subroutine to do it. So I'm going to start off first of all, and this will become clear as I show it and the reason why I'm doing it this way. So I start off, and then I'm going to input in two numbers which are A and B. And then I'm going to imagine that somebody else has done all the work for me, and so that will find out the average for me. So I'm going to put in average of A and B. And so because I'm imagining that someone else has done all the work for me, I do two lines, not quite like that. And this means that it's a subroutine. So somewhere else, someone's written the program or the flow diagram to work out the average. And then all I need to do is just print the result here and end the program or the flow diagram. Now, of course, someone else has had to do this, and what the other person's done, or you will have done in a subroutine, is you will have the other part. So instead of a start symbol, you're going to have average of A and B, and that's instead of my start. That then leads to the total being A plus B, and so that's processing. And then it needs to do more processing, so it needs to take the total, or actually the result will be the total divided by 2, and that's more processing. And then we'll say exit. So what's happening here, it's inputting A and B, it's then going to average with A and B, and it's working out the result in average, and then it's coming back to here and printing the result out. Now the reason that we use subroutines to do this is obviously I can reuse that part of the flow diagram again and again and again. So if I need to work out 100 averages, I could just do one of these boxes 100 times instead of working out the whole thing. And so now we're going to look at how these flowchart symbols, what they mean and how to use them. And so for the first one, this is start or end. So we just write inside something like start or begin. This one here, the parallelogram, is used for inputs and outputs. So I can say things like input A or print hello. This one here is a decision, and remember for these I will have coming out of it and label it a yes or a no, or it could be a true and a false. And then you write inside, so maybe is A equal to 10. And then we have processes here, so this is something which goes on inside the computer, inside the machine. So things like a result is A plus B. So this will be a process. And this one here is a subroutine. So things like maybe add A and B, and then somewhere else a subroutine will do that work. And so what we've got here is 3 examples of flowcharts and what the symbols mean, and you should now have a good idea how to make your own flowchart to explain how an algorithm works.